Hello everyone, I'm Imranul. Today I'm going to talk about one of the major issues with using LNG as a marine fuel, which is in-use methane emissions or methane slip, and preliminary results from our study on policy options for its mitigation. This study is part of a larger project looking at the linkages between air pollution and decarbonization for maritime shipping. Before we get into methane slip, let's talk about LNG. The main benefits of LNG as a marine fuel are a significant reduction of up to 100% for SOx and NOx emissions, which are key air pollutants. It is also cheaper and emits up to 30% less GHG emissions compared to low sulfur fuel oil at the point of combustion. Uptake of LNG has increased recently, in part because this fuel can help ships satisfy the International Maritime Organization's NOx and 2020 sulfur regulations. Many hope that it can also help in bridging to the IMO's 2050 GHG targets. However, methane slip or uncombusted methane emissions that occur at low loads in LNG marine engines can be significant enough to completely cancel out any GHG advantages that LNG has, thereby making this fuel a barrier towards the 2050 GHG goal. The goal of this study is to better understand how methane slip can be mitigated and what policy tools can be used to encourage uptake of these measures. We conducted a systematic review to identify methane slip mitigation measures and drew policy ideas from the road and maritime transportation industries that could be applied to reduce methane slip. We then used multi-stakeholder semi-structured interviews to evaluate and propose potential policy instruments for methane slip mitigation. These policy instruments would affect the uptake of methane slip mitigation measures. We followed systematic review protocols and screened approximately 2,200 records. Based on the review, we categorized methane slip mitigation measures into technological and operational categories, such as high-pressure dual-fuel engines, battery LNG hybrid, and cylinder deactivation. The policy instruments, on the other hand, were categorized into market and non-market based categories, such as environmentally differentiated port dues, subsidy programs, engine categorization based on methane slip, and mandatory emission reporting. Although we are still conducting interviews, in this presentation I will highlight some of the key takeaways from our preliminary results. To promote methane slip reductions effectively, financial incentives need to be large enough and easily accessible. Currently, the stakeholders agree that the discounted port dues are not large enough of an incentive to make the ship owners and operators offer any methane slip mitigation measure when compared to their overall operational expenditure. It is more applicable for cruise ships who want to go green. For container ships, though, it really depends on the clients or the shippers' interest in greening their entire supply chain. Currently, no port in Canada is looking into this problem, considering when approaching the ports, the ships are at low loads where methane slip is the highest. There are mixed opinions among the stakeholders regarding the emissions trading and consortium benchmarking due to trust issues within the industry for such credit trading programs, and the bigger players in the shipping industry having the advantage of reaping away all the benefits from these programs. Stakeholders have instead suggested for a stick policy such as carbon tax. They also strongly support carrot policies such as subsidy programs, especially for the ship owners to bring in new engine technology. This will in turn help incentivizing the engine manufacturers. However, for all the policy instruments to function in the best possible way, emission measurement, monitoring, verification, and characterization are an absolute must. Moving on to the non-market-based policy instruments, stakeholders support amending the existing regulatory CO2 indexes to include methane emissions and increasing awareness regarding methane slip mitigation among ship owners and operators. However, not every ship owner or operator is able to adopt operational measures such as cylinder deactivation or avoid running at low engine loads due to safety issues and operational constraints. Moreover, such measures are not as effective compared to the technological measures in reducing methane slip. Therefore, the strongest support is for regulating engine standards and manufacturers to make better dual-fuel engines in terms of reduced methane slip. As all these stakeholders unanimously agree and consider engine technology to be the single most important bottleneck of this entire methane slip problem, and that the policy interventions for this problem should preferably happen at the ship design stage and not when the ships are in operation with their existing assets. The stakeholders agree that all the policy instruments, including monitoring and verified reporting of methane emissions and engine operational logs, should be mandated in order to achieve the desired outcome in terms of complete methane slip reductions. All things considered, with respect to methane slip, some stakeholders agree that LNG as a marine fuel will be phased out in the future, keeping in mind the 2050 GHG targets. Our next steps are to complete the remaining multi-stakeholder interviews and the systematic review, and then proceed with policy analysis and evaluation. Lastly, I would like to thank MyTex and MEOPAR for the funding. Thank you for your attention.